Hi everyone, this is Roman, and today I'm going to go over a few questions for quadrilaterals in circles, or inscribed quadrilaterals in circles. So for the first question here, we're asked to show that the opposite angles of a cyclical quadrilateral are supplementary. So let's take a look at the two angles we have. We have angle alpha and angle beta. So I'm going to just write alpha in red here. And I'm going to show the arc that alpha intercepts in red as well. So what we could say here is, since angle alpha is an inscribed angle, we could say angle alpha is equal to 1/2 the arc it intercepts, or in this case, DAB. We could do a similar idea here with angle beta. Right? And angle beta is going to be 1/2 the arc that it intercepts, using the definition of an inscribed angle. So angle beta is equal to 1/2 arc BCD. Well, from here, we should notice that the red arc and the blue arc make up a circle, and those arcs are going to add up to 360 degrees. So let's see how we can manipulate this to use that fact. So if I add, use black ink for here, if I add angle alpha plus angle beta, well, that gives me 1/2 arc DAB plus 1/2 arc BCD. From here, what I could do is, I'm going to bring angle alpha plus angle beta down. I could factor out the 1/2, and I'm left with arc DAB plus arc BCD. What do I know about arc DAB and arc BCD? I know that they add up to 360 degrees because they make up a circle. So I could substitute that in there. And now I have 1/2 of 360. And what have I proved? I proved that angle alpha plus angle beta, I'm going to rewrite that, are going to be 1/2 of 360. Well, that's just equal to 180 degrees, so they're supplementary. So now, let me take this picture and let's do a variation of this. So let's say in green here, I'm going to highlight the arc that angle ABC intercepts. So angle ABC intercepts the green arc right here. And if I do the same thing for angle D, which I'm highlighting in yellow, I should notice that the yellow arc and the green arc also make up a full circle. And they're also going to end up adding up to 360 degrees. So this is a way to show that opposite angles in a cyclical quadrilateral are going to be supplementary for a basic understanding of the idea. So let's take a look at some more questions. So in this question, we're shown in the diagram below that quadrilateral DEFG is inscribed in a circle and angle D is 86 degrees in that diagram. We're asked to find arc GFE. And we'll notice we have two questions here. So we're asked to find arc GFE. I'm just going to leave it right there for now, and then we'll worry about stating angle F. So for GFE, I'm going to highlight that arc. Well, if I take a look at that, it looks like angle D is the inscribed angle that intercepts that arc, which means arc GFE is going to equal 2 times that inscribed angle of 86. Right? And then if we calculate that, and we do 86 times 2, we'll get 172 degrees. Make sure we have our 86 degrees here. So that, and I can put the M here, that's the measure of angle GFE. So now let's take a look and see if we can figure out what angle F is, or the measure of angle F. Well, we can think about this in two ways. Based on the last example that we just did, we can notice that angle D is opposite angle F, and we know that opposite angles in a cyclical quadrilateral are going to be supplementary. So we could say this is going to be 180 degrees minus 86 degrees. And that's going to be the measure of angle F. So if we do 180 minus 86, we're going to get to our answer, or 94 degrees. And I'm going to call that method 1. So let's say we want to do a different method, or method 2. So for method 2, if we just found out arc GFE was 172 degrees, well, we could figure out the rest of the arc, which I'm going to highlight in red here. So I'm highlighting it in red. And that's going to be arc GDE. So if I want to find arc GDE, I'm going to do 360 degrees minus 172. So again, if I do 360 minus 172, I'm going to get 188 degrees. Why is this helpful to us? Because angle F is an inscribed angle, and angle F is going to be 1/2 the arc it intercepts, which in this case is our red arc GDE. So angle F would be 1/2 of 188, which is equal to 94 degrees. So those are the two ways to find angle F. Let's take a look at one more question. So in our third question, we're giving an accompanying diagram, and let's label this our third question. And we have quadrilateral ABCD inscribed in circle O. We're told the measure of AB is 132, and we're told the measure of BC, or arc BC, is 82, and the measure of arc AB is 132. We're asked to find angle ADC. So what we should notice here is that our inscribed angle intercepts arc ABC, and for our purposes, we're going to have to add these two numbers, 132 and 82, to figure out what our inscribed angle is. So let's write that out. So we have angle ADC is going to be equal to 1/2 the arc it intercepts, which is ABC. And we could substitute and say, well, ABC, or arc ABC, is going to equal arc AB plus arc BC. So let's use these numbers that we have here. We have 1/2 arc AB is 132 plus arc BC is 82. And that should give us our answer for angle ADC. So if we do our calculations here, we're going to have 132 plus 82, which gives us 214. And we're going to say that angle ADC is equal to 1/2 of 214. And if we take half of 214, we get 107 degrees. And there is our 107 degrees for our inscribed angle ADC.